Yo, what's going on? It's your boy Mr. AC, and we are now officially into week number 3 of our exponential learning. So let's go ahead and begin to think about this new idea that we're gonna learn, which is actually called compound interest. So let's go ahead, let's just dive right into it, y'all. Hopefully you're in the rhythm of things and you're feeling good. So let's go ahead and get started. $50,000 is invested in a mutual fund that yields 8% that is compounded quarterly every year. Well, what the heck does that mean? Well, first of all, the word yield means increase. What does mutual fund mean? Well, that's kind of like stocks. Now, if you're not sure what stocks are, we're not really going to dive too much into that, but just think about it like this. If you have a bank account and you put $50,000 in your bank account, it's saying that it's going to grow by 8%. Instead of, let me show you this diagram to the right here. Instead of having your $50,000, right, let's say $50,000 in your bank account, and then if it was just in 1 year, so pretend like it didn't have the word compounded quarterly, right? Let's just say increases 8% every year. That means you invest $50,000 at the start of the new year, and then after 1 year passes by, this money is going to grow by 8%. Now I want you to think about which one's going to be better, this one or this one up here. Well, the one that's better for you is the new one, and let me tell you why. But now let's think about what does compounded quarterly mean. Well, that means instead of having your money grow by 8% one time, that means that it's going to grow 4 times in a year. When you think of the word quarterly, you think of, and I spelled it wrong by the way, sorry, but anyways, when you think of quarterly, you think of quarters, right? There's 4 quarters in a year. Let's go to question 1. What exactly does compounded quarterly mean? Well, let's draw a diagram. 0, let me just draw this out. Boom, this is 1 year or 12 months. So we got to break this up evenly 4 times in a year. So for example, maybe here, and here. I'm going to try to break it up as evenly as possible. Now, what that means is instead of multiplying one time by 8% in that year, it's 4 times in this year. If I take 12 months and break it up evenly 4 times, that's going to be intervals of 3 months. Now, you don't need to really know this part right here. It's just going to help me at least draw this diagram for you. So, for example, if I was to do it like this, right? 3 months, 6 months, 9 months, 12 months, because now it's 1, 2, 3, 4. So it's going to multiply 4 times in 1 year. So that's what the compounded quarterly means, is that your money's going to grow much faster because it's going to multiply 4 times in that year. So let's go ahead and figure this out now. What's going to happen to your 8% when you're compounded quarterly? Well, here's the slight catch. This 8% that we started with, I'm gonna write it up here. It's not gonna be 8% every single time. It's actually going to be spread out evenly. 8% has to be spread out evenly. Compounded quarterly is 4 times in a year. So 8 divided by 4 is 2%. So what that means is, let me go ahead and write it over here. 2%, 2%, 2%, and then finally 2% here. So what we did is this. You're taking the 8 and you're going to divide it by 4 because it's compounded quarterly. If it was monthly every year, it would be 12. If it said biannually, that would be divided by 2. And I'll show you an example of that in a moment. There's 4 sections in every year. That's what we divide by 4. And the percent gets equally distributed among each section. Okay, that's really important. So now what that means is your money at 3 months is going to multiply by the 2% and grow. And then at 6 months is going to multiply by another 2% and grow. And then it's going to multiply by another 2% and grow. And then it's going to multiply by another 2% and grow. Now the percentage is smaller. So you might think that's not great, 2%, but you're multiplying it 4 times in that year. In 2 years, you're multiplying it 8 times. In 3 years, you're multiplying it 12 times. So you can see just how much faster it's going to grow, even with the smaller percentage. So what's our new constant multiplier? So let's write an equation, right? We want to write a new equation. Well, it's going to be, we are increasing, so 100% of our value. Let me go ahead and change it just because this is easier to see right here. 100% of my value plus my percent increase. Well, it's not 8% anymore. This is where it can get tricky. That's the catch. It's not 8% anymore. This is now 2% because we broke it up evenly 4 times in a year. So plus 2%. We add these together, we get 102%. We divide it by 100 to turn it to a decimal, and we get 1.02. Now let's go ahead and write our equation. Y is equal to $50,000, that is my starting point, multiplied by 1.02. And now here's where it's tricky. It's not going to be just X up here. The reason why is if you put an X up here, right, how do you know that this is any different than what we've done in the past? Well, one thing for you to be mindful of is this right here. How many times are you going to multiply this 2% in a year? Well, 4 times. 1, 2, 3, 4. So up here is now going to be 4x right there. So pretty challenging because now you have to get a new multiplier and you have to be careful. It's multiplying 4 times in a year, so it's 4x. So now if I plug in 1, then I know, hey, we're multiplying this percentage 4 times in a year. So how much money does the account have in 3 years? Well, we plug the 3 into the X and we'll solve that out, which we're actually going to do in our next problem. So let's go on to our next one and then we're going to be good to go. $50,000 is invested in a mutual fund that yields 8% that is compounded monthly every year. So what does compounded, that should say monthly. On your paper, it will say monthly. So what exactly does that mean? Well, that means that your money is going to grow and it's going to increase by 8% compounded monthly. Well, how many months are in a year? Well, there is 12 months in a year. So if I go to draw my diagram, this is going to be a little bit more time consuming. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's just go ahead, for the sake of simplicity, let's get rid of this and say 12 here, 1 here, 2. Okay, so I just wrote out the months up here. So what's going to happen? Well, we're going to take our 8% and we're going to divide it evenly 12 times in a year. So here, 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 etc., etc., etc. Very similar to what we did with quarterly, but now you're taking the 8%, you're going to break it up 12 times in a year. So what do? Well, we know there's 12 months in a year. So we're going to get the 8% and we're going to divide it by 12. And that's going to give me 8 divided by 12. It's not going to be a nice number, and that's okay. It's good for you to know. It's going to be 0.666667. For this problem, for now, we're just going to round this and say 0.67. So 0.67%. Be careful. Even though it's a decimal, it's still in its percentage form. So what that means is in here, this is 0.67%. And this is going to be at every single location here. So 12 times in a year multiplied by that percentage. So what's my new multiplier? My new multiplier is 100% plus 0.67%. You have to still be careful. Even though it's a decimal, it's still a percentage. So we get 100.67% divided by 100. And we get, right, the 100% here. We get 1.0067. This is my new multiplier. Now, one thing for you to know is you could also have written it like this. You notice that this is always 100%. So you could write 1 plus and then just turn this one to a percentage. And if you did, you get 0.0067. And if you add these two together, you get 1.0067. So just another way of going about it. If you feel pretty confident, you can just do 1 plus and then just turn this to a percentage and then you can add them and then you're good to go. There'll be a challenge problem like this. We'll leave that to you. But anyways, let's go ahead and write our equation now. Y is equal to $50,000, 1.0067 raised to the power of, well, what would it be up here? How many times are we multiplying this percentage in a year? Well, we're going to multiply 12 times in a year, right? 5, 6, 7, 8, 9, 10, 11, 12. 12 times. So up here will be 12x. So you'll notice 2 big things to take into account for compounding monthly, quarterly, or whatever you're doing. 1, you need to make sure you get your new constant multiplier. And then you need to make sure when you write your equation, the exponent takes into account how many times you're going to multiply that. So now, how much money does the account make in 3 years? We'll plug the 3 into here. And we're going to get Y is equal to 50,000. I know I wrote it really small, but there's 12 times 3 right here. So let's go ahead and plug it in. I'm going to put a set of parentheses and do 12 times 3 like this. If you look at my calculator right here, 1.0067 raised to the power of 12 times 3, and we get 63,587. So $63,587 point approximately 60 cents. And there it is, my dear students. that's how much it's going to cost, or that's how much you're going to grow your money wise in 3 years. I mean, that's a good amount. In 3 years, you've grown this by, it looks like, $13,000 and $13,500-ish. Pretty dang good money. So hopefully that makes sense what this whole compounded quarterly monthly means. We're going to go ahead and look at one more problem that involves graphing.